All right, Dr. Hershkowitz here. Today we're going to be looking at Hooke's law. What do I have here? I've got a spring, and when the spring stretches, we say it extends. The extension is how far the spring stretches, and I can measure the extension using a ruler. So what am I going to do? I'm going to apply a force on this spring, and it's going to pull the spring down, and the spring is going to extend. Right now, the force on that spring is 0, and the extension should be 0. Okay, now I'm going to add the first force, which is exactly 1 Newton. And that Newton will be weight, and that weight is going to pull down. So there we go. That is a force of 1 Newton on the spring. And can I measure the extension? Yes, and the extension is about 3 centimeters. Now what do I do next? I have to increase the force. Instead of doing 1 Newton, I do 2 Newtons. So I now put a second weight on. The force is now 2 Newtons, and the extension is about 6 centimeters. So I write that down. And what should happen is that as I double the force, I double the extension. So if I plot it as a graph, I should get a beautiful straight line. Okay, so not all springs are the same. Some are really stiff and hard to extend, and some are quite easy to extend. And we say that different springs have a different spring constant. And that spring constant, we give the letter K. Now, so stiff springs have a very high value of K, and springs which are quite easy to stretch have a low value of K. And there's an equation you need to know that the force, remember the force that hangs down on the spring, equals K, the spring constant, times the extension in meters. So F equals K times E. Right, now, if I'm adding my weights onto my spring, and I take the weights off, the spring should go back to its original length. And that is called elastic deformation. The spring goes back to its original length. But at a certain point, essentially I break the spring and I reach the limit of proportionality. And at that point, if I stretch my spring, it won't go back to its original length. And we call that inelastic deformation. Now, if you can remember back to thinking about stores of energy, there are different types of stores of energy. We've got chemical, we've got thermal, we've got kinetic, and we've got gravitational potential energy. And they are all stores of energy, which is measured in joules. Now, a stretched or extended spring also has a store of energy, and we call that elastic potential energy. And there's an equation you need to know, and this is it. The elastic potential energy equals 1/2 times K, the spring constant, times the extension squared. So EPE equals 1/2 times K times E squared. And that's the equation you need to know.